Alright, let's get started with MultiSIM. Now, MultiSIM is a circuit design software, or a CDS for short, that allows you to do very many things in it. You can build simple circuits all the way up to handling your counters for your date of birth project later on in the semester. When you open up MultiSIM, you should see a screen similar to mine, where it has all these different toolbars, all these different buttons, and it's got a blank workspace. Now I'm able to zoom in and out on this workspace by scrolling with my scroll wheel, and I can also pan around the workspace by clicking and holding middle mouse. Along the top, there's a series of buttons that allow us to place various types of electronic components, and there's also some buttons on the side for testers for these components, such as a multimeter. Up in this top corner, we have some of the more explicit testers, like our ammeters, which measure current, probes, which show if a circuit is getting power or not, and then voltmeters for measuring voltage. Let's get started building a simple circuit with a few different resistors in it. So I'm going to utilize this space to build that circuit. Now, to place my first components, I can do a few different things. I think I can go up to place component. But you can see that there's also a key shortcut for it, Control W. So in this open space, if I press Control W, it brings up this large window. Now, this component window, you can see down here, there are 53,942 components. That's because we're searching in the master database and all groups. If we know specifically what we're looking for, we can find it in this family of groups, such as diodes. There's all sorts. There's still 1,000 different diodes. We can place things like our inductors. We can place lamps. There's all sorts of stuff that we can place in MultiSIM. For my purposes, I like to keep it on all families, all groups, always in that master database. So I can just come up here and say I wanted to find a resistor. I can type in the word resistor. And MultiSIM has 3 auto-filled ones. You can see there's sort of a cartoon graphic here for them. Or it has what's called a rated resistor, where you can edit the rating of this resistor to suit your needs, whatever they may be. Now, to build circuits in MultiSIM, we need a few different components. We need our resistors, our LEDs, whatever it is that we're sending power to, but we also need a way to provide that power. There's a few different types, but for this purpose and for this class, we're going to use a DC power for starters. Now, if I type in the word DC, it will filter out anything that has the word DC in it, or the letters DC. Our hex displays, whatever this might be, a 3 to 8 decoder, it tells you what it is if you don't know. Here's a 2 to 4 decoder. There's all sorts of stuff. What I'm concerned about finding is DC power, this one right here. You can see that it looks very similar to those symbols that I draw on the board. When I found it, I'm going to click OK, and now I can place that component. Place it wherever, it doesn't matter where. When I've placed it, it brings back up my select component window. If I want to get out of this window, I can click the X, I can hit the escape key, and it will close that window. Now if I want to reopen it, Control W. For this circuit, I'm going to use 3 resistors. And I'm going to make sure I use the resistor rated resistors. So I'm going to double click and place 3 resistors. You can also copy and paste resistors. However, it will copy and paste the exact value. So if you modified these, it will copy that modified value. Say I placed 1 resistor, say I placed this one here, and I set it to be 13 mega ohms. If I copy and paste it, the other ones will also be 13 mega ohms. But it doesn't really matter as long as I get 3 of them placed. Now your screen may look a little different than mine. You may be seeing some values associated with those resistors and this power source. If I double click on one of my resistors, I can edit the values. Here I can see I can edit it from being a 1K resistor by default to, let's make this one 330 ohms. If I say OK though, it doesn't show me that. So if yours doesn't show you as well, what you do is you double click, go to Display, show component specific visibility settings, make sure labels and values are turned on. The rest of them do not matter for this purpose, but we want our labels and our values. Now when I click OK, notice how it gives it a name, R1, and it displays the resistance 330 ohms. So let's do the same for the other resistors. You can see it defaults to this display tab because I was using that display tab moments ago. So now I have 3 resistors. I'm going to turn on the settings for the power setting as well because let's see what we're working with here. By default, this is V1 for my power source and it's 12 volts. I'm not going to modify this, but if I wanted to, double click and I change my value from 12 volts. Don't worry about the rest of these settings because it's higher levels of electronics that we typically don't care about in this class. So I've got my resistors, I've got my power source. One other thing I need in this simulation software, because it is a simulation, is a ground for this circuit. If I do not ground my circuits, they will not operate correctly. So I press Ctrl W to place a component, and I'm going to type in the word ground. Again, there's all sorts of different types, but what I want is just analog ground, and it looks like this. Double click, and I can place it in. I don't need any text for this, but if I wanted to, I can double click it without moving it. Oh, and it actually doesn't look like it can edit it, so never mind. You can't put any text there. Now I want to make these resistors in a series circuit, meaning I want the current to flow out of the top side, in through resistance 1, through resistance 2, and through resistor 3, and back into the negative side. However, resistor 2 isn't in the most optimal position for that. What I can do is right-click and say rotate 90 degrees clockwise or counterclockwise. It doesn't matter here. And now it is in line, better suited for my circuit. And I can move this voltage up if I wanted to. I can move the ground down. I can also do this after actually building the circuit. As of current, we've just placed our components. We haven't actually built the circuit. We haven't connected them. To do that, if I hover near the ends of one of my components, the leads, if you will, you can see this little black dot with a crosshair appearing. If I left click, now it's like I'm drawing wire. So I'm literally drawing wire to each of my components. For me, I have it defaulted to red, but if I double click it, I can change the color of it. This will be important later on when we have very involved circuits, like all of our counters. We're going to want to have different wire colors to show positive, negative, circuit 1, 2, 3, and so on. But for now, I'm going to leave it red. I'm going to continue connecting all of my components and this ground component. Now I'm going to connect this ground component up here, and notice the path of the wire. It's not overlapping the already placed wire. Unless I go to one side or the other, then it will cross over it. But MultiSIM does a really good job at trying to keep your work area nice and tidy. Now you can always go the extra mile and tidy it up some more, but yeah, it tries to keep things nice and orderly. Now say you placed your component end there. You connected the wire from this component, the ground, to the circuit all the way up here, and you don't like that placement. Well, instead of deleting the wire, what you can do instead is notice if I hover near the end of it, I get this option that sort of looks like an X with 2 lines coming off of it. That X with the 2 lines coming off of it allow me to change that connection point. If I have it up here between the dot and the power supply, it will move this third section of wire. Notice now, this is not one continuous wire. It's been split up into 3 groups. So if I want to move this wire, I have to click here to detach it based on this end here, based on this wire here, and I can detach it and reattach it in a better suited spot. Now my circuit looks great. I'm going to change the voltage of this resistor to be 1.5 ohms. I meant 1.5 kilo though. Now I can type in 1500 and that is 1.5 kilo ohms, but we know in SI notation that's not going to fly. So I'm going to change this to 1.5 K. MultiSIM does recognize that as 1.5 kilo ohms, and it will appropriately incorporate that to the circuit. And I'm going to change this resistor to 770. Now I have my circuit built, and if I click the play button, you'll see this message pop up. It's talking about probes in an interactive simulation. That's not a huge deal. Don't worry about it. But if you do have errors, they will appear in this window. I can still click on things, I can move things around, I can change the values, but notice if I change this to 18 volts, it will tell me the simulation is running. Any changes you made in design will not take effect until you restart the simulation. So I can say okay, and that'll be 18 volts, but because I am running my simulation, I cannot see that change happen. So I'm going to stop the simulation and start it again. Notice that there's a play button, a pause button, and a stop button up here. Run is F5, pause is F6, stop does not have a keyboard shortcut, so keep that in mind. Now I have my circuit built. I want to take some voltages about these circuits. I want to find out what are my measurements. So if I hover over these various components, here is a voltmeter. I can place my voltmeter, and if I connect the positive to the positive side of the circuit and the negative to the negative side of the circuit, let's move this so it looks a little better. I can press play, and this thing will start reading, and there it says 18 volts. And that makes sense because I have 18 volts in my circuit. I start with 18 volts, I have to end with 18 volts. But we know that in a series circuit, voltage drops across various components. I can read the voltage drop across these various components by taking my voltmeter to them. So if I press play now, we'll see what my voltage is. At this component, it's negative 5.33 volts. And that's not really important that it's negative, it still gives us the correct value. But the reason it's negative is because, remember, current flows out of the positive side and into the negative side of our source. So it's coming out this way, going through that resistor, this resistor, and then it's branching off right here to the voltmeter. But this voltmeter is the negative side. So if I've got the negative on the positive side of my current, because of how it flows, remember clockwise or out of the positive into the negative, then it's going to give me a negative voltage reading. If I move my wires around, or you can see I made a mistake there, that doesn't need to be like that. This one needs to move over there. I stop the simulation and restart it. Now I'm getting the correct 5.33 volts. And if I did my math correctly and I found the current running through this circuit and then used Ohm's law using this 770 resistance ohms resistor, then I should find 5.33 volts approximately. Even MultiSIM does some rounding here. I can also drag in additional voltmeters for every single component. So I'm going to wire up this one, and I'm going to move everything down some. To move everything, click and hold, left click, and it selects everything. Now if you come over one of your components and click and drag with left click, you can move everything at once. If I missed a component, it would have stayed up here in the corner, and it would have made my wires all sorts of messed up. So make sure if you want to move everything that you select everything. I press the escape key there to deselect it. I'm going to drop in one more voltmeter, positive to the positive side of our current, negative to the negative side. And now when I press play, I get 2.285 volts, 10.384 volts, and 5.331 volts. Now if I open up a calculator and I type in 2.285 plus 10.384 plus 5.331, I get 18. And I should. Remember, the sum of the voltage drops across components is equal to the voltage you start with. That's great. That's how we use voltmeters. But what if we wanted to use an ammeter? This one right here, an ammeter, which measures amps. Well, if I take this guy and I put him on the negative side and the positive side, and I press play, I get a reading of 7.933 milliamps. Great. What if I change it from here to across this guy? Let's go from across component number 2. If I press play, It's 0.016 amps. But we know that in a series circuit, the current stays the same. So something important is going on here. In order to measure current, recall that the current has to flow through the ammeter, meaning I have to take a wire, connect it to the positive side, and take a wire and connect it to the negative side of my ammeter. I have to. It's the only way this is going to work correctly. Now if I press play, I get 6.921 milliamps. So to find current, it's I equals voltage divided by total resistance. So if I have 18 volts and I divide that by 330 plus 1500 plus 770, I get 0.006923 right there. That is whole amps, because remember, it's whole volts, whole amps, whole ohms. Base 10 to the 0. It's our base unit. SI notation says I have to move this decimal point 3 spaces to the right. So the decimal point will end behind the 6, and it will be 6.92 to 3 here to 1 in my circuit simulator. But that's okay. That is close enough, 0.02 off, that I know that this is accurate. This is accurately reading my current. The reason for that is because MultiSIM, like I said, is a very good software for simulating. There's resistance in this power source. There's resistance tolerance in these resistors. MultiSIM knows that, and it's actually finding a more specific current. But for our purposes, we don't have to worry about it being ever so slightly off. This is where that error comes into play. So that's how you build a very simple series circuit.